Okay, so hopefully you've gotten really good at these dimensional analysis questions. You don't have to practice all of these, but here's some to start with anyway. V is equal to AT. Write down what you're going to change. Velocity, meters over seconds, or ms to the minus 1. We're going to change acceleration is meters over second squared. And time is equal to seconds for units. So we're just looking at the units here. So on the left, we're going to have m over s. On the right, we're going to have m over s squared times s. That s to the power of 1 on top, s to the power of 2 on the bottom will just become s to the power of 1 on the bottom. So you're going to get m over s. Therefore, m over s is equal to m over s QED, and so on. Hopefully they're getting easier than they seemed at the beginning when you're totally confused by s is equal to s and s is equal to seconds and all sorts of stuff. Right, s is equal to a half v. S is displacement, which is measured in meters. A half is just a constant, we'll leave it out. And v is equal to, I'm just going to write it here, v is equal to m over s, ms to the minus 1, I'm so used to saying. Time is in seconds. So you can use this for therefore, or you can use the arrow with the equal sign as we did above. These are all the same thing, just getting you used to how to write into your copies. Take pride in what you're doing now. Applied math is not an easy subject. You do have to be meticulous about how you take notes. So you have VT, we've gotten rid of the half. So V m over s, t is equal to s. So s on the left, your meters, is that equal to V, which is m over s, times t, which is s. S divided by s would be equal to 1 if there was a 1 needed. So we have m is equal to m. Again, QED. 3, V is equal to u plus AT. So because we've already replaced V, we've written it down up there. We could write m over s is the left. U is also meters per second. Acceleration is meters over second squared. And time, we're looking now at the last part of this, time is also seconds. So you get meters over second is equal to m over s plus m over s. You could write 2m over s, or you could just write units same. QED. 0 to number 4 now. Force is equal to mass times acceleration. This one here, I'll just write it out again. So nobody is asking you to memorize these in applied maths. You're always going to go back, find the right equation, take your time. So force is equal to ma. Force is kilograms with acceleration, ms to the minus 2. This m, mass, is kilograms. You can see here, mass is kilograms. We haven't replaced that before. And then replacing a with also ms to the minus 2. And I should probably not be going over this far. You can see here straight away the left is equal to the left, or the left is equal to the right, because I'm two left hands. The left is equal to the left. So let's look at the next one. Number 5 here, s is equal to ut plus a half at squared. Another famous equation we're going to see a lot of. So we know s is displacement, which is in meters. This is equal to u, which is ms to the minus 1, or meters over seconds, times time, which is in seconds. I'm just drawing the arrows to show you which one is which. You don't have to do this in the simplifying in an exam. Acceleration is ms to the minus 2, or meters over second squared. The half is a constant, we're just looking at units, and time squared is going to be s squared. These two cancel, and so do these two. M is equal to m plus a half m if you want to leave it in. That was supposed to be an m. Units equal units. That's all we're looking at in these first couple of videos. Nice easy intro for you into applied maths. Question 6, s is equal to a half u plus v times t. Don't panic, Just write it out. S is equal to a half, which we don't need, it's a constant. U plus V times T. Always write the question out again. S, displacement, is measured in meters. Is that equal to a half of something? You can leave it in if you want. Initial velocity, U, is going to be m over s. Final velocity, V, is going to be m over s. We'd have to multiply that by time, which is measured in seconds. You can see all the replacements here. That's all you're getting used to doing. And then you're going to be, if you can do these, you can actually do applied maths. We're going to have, if you want to simplify this, we have m over s plus m over s. Leave the half in, we have a half of 2m over s times s. If you want to be really elongated about doing it, the s's cancel, as do the 2's. M equals m. Up here you could have cancelled the s with those two, and at that point said m is equal to 2m over 2, or m is equal to just m. Just don't jump to the answer too quickly, don't be a smarty pants. We'll do 7 and then I'll leave you with the rest to practice. And it is just about practice makes perfect, don't not practice them. So t squared, I'll write it out again, t squared, distinguish what you're doing, is equal to 4 pi squared. 4 pi squared, this looks complicated, but 4 pi squared is a constant, it's just a number, so we don't need it on line 2, times L over G. I'll just put in the times dot. Time, measured in seconds, so s squared. Is that equal to, it doesn't look like it's going to be, but what is L? L is displacement, it's measured in meters. Gravity is acceleration, which is ms to the minus 2, or meters over second squared. And we had this example earlier where we divide by a fraction. You're going to see this a lot. That's why they're setting you up to be able to have this skill. This becomes m squared, s squared equals, I'll do the m first, m times s squared over m. And hopefully you're seeing the repetition here of the skills involved in simplifying these equations. S squared is equal to s squared, QED. Move on, do the rest yourself, and hopefully you're building confidence that applied maths is the subject for you.